All right, guys. Uh, this week's going to be a little bit tougher than normal because we are working with what are called trig identities. Now, the trig identities, sorry, guys, those are found on 12.1. So let me look up the page for you guys real quick. There's a specific page. And then solving equations is on 12.5. And so the trig identities you need to use are on page 725. And then the other information that you need is on page, sorry guys, I'm using my computer here. 753. It starts on page 753. So we've got the solving equations, which is where these come from. And then to solve these equations, we need to have the table. There's a table on page 725, which is section 12.1 for our trig identities. Now, before I get into the trig identities, they're going to give you guys problems that look like this, where you have cosine. So if we look at this problem, we have cosine and sine in here. And so as we look at this, it's like, okay, I'm not sure how to solve that, so we're going to tackle that. And then it tells you to only find answers. That's what this is. This is our domain. In other words, my answers can only be between 0 and 180 degrees. There can be no answers outside of 0 and 180 degrees. So that's what that tells us there. So we've got a couple of options here that I want to show you. So if we treat these like variables, so let's just say that cosine, I'm going to make x. So I'm going to say let cosine of theta equal x. And then I'm going to make my sines y. Sine y. And so what I'm saying here is I'm saying let sine of theta equal y. So I've just changed my sines into y and my cosines into x. You don't have to do it this way, but I'm just showing you kind of a different way to look at things. So now I can look at this and I can say, oh, y is my greatest, is a common factor. So if y is a common factor, I can divide out my y. So I'm going to take a y out, but divide a y out. So then I get this. I get y, because I divided it out, and then whatever's left. So what's left? My x is left, and my negative 1/2 is left. So x minus 1/2 equals 0. Oops, I forgot my equals 0. So all I did was take a common factor out. Then I just replace everything. Y is sine of theta. So the sine of theta is equal to the cosine of theta minus 1/2 equals 0. And so at this point, I can set each factor equal to 0, and I can go the sine of theta is equal to 0, and the cosine of theta minus 1/2 is equal to 0. So we get the cosine of theta equals 1/2, and the sine of theta equals 0. So then we go, okay, from 0 to 180, where is the sine of theta 0? Well, its answer is at 0 and 180 degrees, which fits in our domain. Our domain right here is between 0 and 180 degrees. So where is the cosine 1/2? Well, it's positive 1/2 at 60 degrees, so theta is equal to 60 degrees. And those are my two answers, or three answers, I should say, 0, 180, and 60 degrees. So remember, treat these guys like variables, and it'll be a lot easier there. Okay, so let's slide up and tackle our ones that give us sine and cosine, but they give us a little bit different look to them. So that is not as pleasant. So if you go to the identities, on page, what did I say the page was? If we go to the identities on, let me find that, guys. I can't remember the page. 725. You're going to have to use these. Go to the identities on page 725. Go down, about a third of the way down, and there's something called the Pythagorean identities. And one of them says cosine squared plus sine squared equals 1. All right. So we're going to use this particular one here. And it also, there's another one that's tangent squared plus secant squared. Tangent squared plus 1 equals secant squared. That we could use in a different type of problem. So when we're looking at these, I can't factor anything out of this. It just doesn't work. So I'm going to use this identity to change one of these. I don't care which one you decide to change. It doesn't matter. The answer is all going to be the same. So I'm going to take cosine squared and I'm going to change it to make it into sine squared. So I'm going to change cosine squared theta into sine squared, into a sine identity. So, but if we look at this, we're like, well, I can't tell what it is. So I'm going to actually solve for cosine squared. So I'm going to solve for this, which means I'm going to subtract sine squared from both sides. Oops, I don't want that equal sign. And I'm going to subtract sine squared. And so that means cosine squared is equal to 1 minus sine squared. So now I have cosine squared, and I also have it in a different looking identity. So this means that cosine squared is the same as 1 minus sine squared. Well, now I can use that here. I can say let cosine squared theta equal 1 minus sine squared theta. So I'm going to rewrite this as 1 minus sine squared theta plus 2 sine squared theta equals 4. Look what happened here. I took cosine squared theta, I changed it right here, telling it to equal the trig identity, and then I replaced it. Okay? So now we can clean all this up, and we're going to rearrange things. We're going to get 2 sine squared theta minus sine squared theta plus 1 minus 4 equals 0. So if we do this, 2 sine squared theta minus sine squared theta minus 3 equals 0. Now we can treat this as a factorable problem. So if I look at this, I can, again, change my signs to x's, so I get 2x squared minus minus x minus 3 equals 0. Now I can factor this into two pieces, and I'm going to get 2x, and I'm going to get negative 3 plus 1. 2x times x is x squared. Negative 3x plus 2x is negative x. Negative 3 times 1 is negative 3 times 1 is, I messed up here. Hold on. That is just going to become sine squared, isn't it? Here, back up. We don't need that right now because I didn't look to see that this here is these are like terms now. So then I can 2 sine squared theta minus sine squared theta gives me sine squared theta minus 3 equals 0. So sine squared theta equals 3. So then sine of theta is equal to the square root of 3. And then if we take the inverse sine, theta is equal to the inverse sine of the square root of 3. And that needs a calculator of some sort, and I don't know what that's going to be here. So let me find out for you guys. So we are going to, oh, hold on. So what do we got? Square root of 3. 3 square root equals trigonometry, second inverse sine. Oops, clear. All right, so we get, hold on, guys, I'm sorry. 3 square root, where'd it go? There it is. Oh boy, I can't use this calculator. There it is. We get theta equals the sine of negative 1/2 of 1.7. Well, you're going to find out that this is going to give you an error in the calculator, and so this one has no solution. So the biggest thing I want you guys to understand is that you have the ability to change things using your Pythagorean identities, okay? We're going to do, so these are the things that you got to work with on page 725. So make sure you guys look at that on page 725, and we'll do some more examples in the second one.